We're starting on, we have enough videos for today. Okay, so who has joined us? KS Lau. Hi, KS Lau is also in. Hi, KS Lau. Can you say hi? KS Lau, is it your name? You can unmute and just say hi. Welcome to the lesson. Okay, let's jump straight into the question so you guys participate a lot more. Finally, guess what? My prediction came true. I have 4 students now. Justin, Kim Seng, KS Lau, and Mok En. Just as I said. Okay, so let's move on to question 1. Okay, now we have 10 MCQ questions and 1 open-ended questions, and once we finish, we are done for today. Okay, but I went through this a few times and I find these questions, although they look easy, but they really test your knowledge quite a bit. So I want to see how many of you get it right and wrong. Okay, so let's put up a poll so you can actually answer it. Okay, make sure you participate. Okay. All right. So an atom is electrically neutral. It's neutral because all right, there's an equal number of electron, proton, neutron. Is that correct? Worth thinking about, right? Give you all another chance. Okay, I'm going to end the poll. D is the wrong answer, so I'm going to give you all another chance. All right, launch poll again. Think about it and go. Okay, now you all change your answer to B. Okay, so share results. The people in the class who are participating are answering as B. There's an equal number of, very good, because electrons is negative charge and protons is positive charge. Only if they are equal, they can be neutral, right? So you must have like 5 minus 5 plus, right? If you have 5 minus and 4 plus, that would be not neutral. There is a negative charge balance of 1. Okay. Now, after I ask you all to rethink, okay, now I think you got the answer. So only electrons and protons have charges. Neutrons do not have charge. That's why they're called neutrons, because they're neutral. Okay. Neutrons, no charge, which also means they are neutral, which also means you can say 0 charge. Okay, so they do not contribute to any minus or negative or positive charge. However, on the other side, right, you have electron, which is usually like that, and proton is usually like that. It really clearly already shows you that they have a charge together. All right, so you can add up the number of electrons. If it's 5 and 5, 4 and 4, 3 and 3, then they are equal. They cancel each other out. Therefore, they are neutral. Okay, therefore, atoms usually have the same number of 1. So here we'll have 1 plus, 2 plus, 3 plus, 4 plus. Why 4? because outside I see 4 electrons. So inside you'll have 4 protons. So that's why it makes an atom neutral. Obviously, I'm not talking about the neutrons yet. If I want to talk about the neutrons, I can. Let me show you. The neutrons will be, these are the neutrons. These can be any number depending on what is shown on the periodic table. It doesn't have to be equal to any proton or electron. They have their own unique set of neutrons. Okay, it could be 5, it could be 3, it could be 2. We'll study that more in detail as we move across the questions. Okay, let's do question 2. Okay, as we do every question, I want you to think about the answer first for about 15 seconds, and then I will launch the poll. So think about the answer first. Would you want to key in A, B, C, or D in this? So if I launch the poll later, you can enter it. But right now, think about it first. What is situated inside the nucleus? I think I just drew it out. So, and what is outside the nucleus? Just now I just drew it out. What is inside the nucleus? And what is outside the nucleus? Right? So outside will be electrons. Inside will be two types of particles. Let's redraw that again. Right? That is, so let's see if you can find the answer. I'll give you a chance to put it in while I draw the final diagram. I have to draw a few more electrons to make it neutral. Okay. Must they always be neutral? If it's an atom, yes. If it's an ion, no. So in the back of your head, you might want to think about what is an atom versus what is an ion. Okay. Ions have charges. Okay. So an atom like calcium is neutral. An ion like will become like a 2+ because there's additional 2 protons compared to the electron. That means something wrong somewhere. What happened? These 2 electrons flew away. Can you see? So because these 2 electrons flew away, what happened is you have 4 protons and 2 electrons. So you have a 2+. Okay. The number is not exactly from the periodic table, but I'm saying there's an excess of 2 protons, which makes the charge 2+. The moment you make a 2+, you call it an ion, not an atom anymore. All atoms are neutral to begin with, but they become ions the moment they lose or gain electrons. Okay, so I'll leave you at that as we go to number 3. Now, this is another simple fundamental understanding question. Let's see if you, this one can be quite fast, right? Very good. The first person who answered, very good. Whoever entered. The rest of you, are you all really very weak in atoms or molecules? Please share your comments on the chat. I mean, it's private chat. Maybe I can make the chat only host can see, then not everyone can see. So whatever you type in the chat, only I can see. So you're having trouble with the topic, right? Please let me know so I can slow down or explain something, okay? Because it's a small class, I can address your questions more intimately, okay? So that we get a better experience of this session today. All right, I've got 2 answers and both of you mentioned that B, okay? So I think based on the question, right? 1 and 2, we already identified protons and electron must be equal, proton being the plus and electron being the minus, right? They must be equal, right? Then they will be neutral because it's atoms, right? Because it's atoms, not ions. So take note of this keyword that they have identified as atoms, not ions. So that's why it's important to know the difference between ions and atoms. Okay, so I mentioned to you, an atom looks like this, an ion looks like this. An atom of sodium looks like this, an ion looks like this. An atom looks like this, ion of chlorine looks like this. So what happens is, this is when they form a partnership, because one is a plus, one is a minus. What happens is they pair up to become neutrals. Because when they are ions, they are a bit unstable. So to become stable, they go and look for their partner. So the plus will look for a minus, and because the plus will cancel out a minus, will become a neutral compound called a NaCl. What is NaCl? Anyone can type for me the full name of NaCl. NaCl, how many elements are there? 4 or 2? 2 elements. What are the names of these elements? Who knows? It's a test. It's a small test. Earlier, Harry Potter could shoot off 100 over names. I'm asking you only for 2 names. Give me 2 names that refer to Na and refer to Cl. What is it? Or at least just type 1. Don't be afraid. Come on, just share. What is Na? Is it nasty? And Cl is it clear? Nasty clear? Or what? Okay. So today all the work has to be done by me, is it? Come on, guys. I already did this when I was 14 years old. I need you guys to do it. Okay, how many years more you want me to do theoretical? Like I'm the one doing the homework. Okay, you guys don't want to do. Your teachers and parents will be proud if you do, because it will show in your results. End of the year, it will show. Okay, but I'm still happy that you guys attended it, right? Attend today, like you spend 1 hour with me. I'm sure you will go away with some learning. Okay, sodium chloride, all right? Clear? Okay. Let's move on to the next question, next challenging question. All right. Elements. How are they arranged? Any idea? How are they arranged? We have a periodic table, left to right, top to the bottom, but how are they arranged? Are they arranged according to the number of what? What is unique about each element? All of them have a unique number of neutrons, number of protons, proton, neutron, electron, proton, neutrons. What gives them the identity? Okay, let me draw for you. So this is the periodic table example. As I move across, what do you think increases? Okay, you have one more extra. And not proton, neutron, and electron, not all, but mainly protons only. Okay, protons will increase, but electrons, obviously they increase together. But electrons, sometimes they can be removed and added. So so they are not placed in a periodic table because of their electron number, but because of the proton number. And neutrons is all can be as many. There's no pattern. Okay, so it can be as many as the element has. Okay, so both of two of you who answered D is the wrong answer. The answer is A. Okay, elements are arranged according to the number of protons. Okay, take note of that. Protons. Later there'll be another question similar to this. So you must remember question 4. When I'll try and say, hey guys, remember question 4, and then you must remember. Okay, remember? Okay, let's go. All right. I think this one is pretty easy. Just take 20 seconds, or 20 seconds to answer this. I will launch the poll in 20 seconds.